Hello, I'm Andrew Littleton. I have a problem here asking us to find the inverse Laplace transform of this polynomial. So we look at this and we see there's this e to the minus 2s term that we don't usually, or have maybe not used to seeing when taking the inverse Laplace of these polynomials. And all it is it just illustrates, it's part of this property that says if we have some function f of t minus a and we take its Laplace transform, then that Laplace transform will be e to the minus as times the Laplace transform of your original function. And so what that means practically is that for now we will let f of s equal 2s plus 5 over s squared plus 5s plus 6. And we know how to deal with that, so let's see what happens with this. So what we first need to do is break up the denominator, or factor the denominator into both of its factors. So we'll get 2s plus 5 over s plus 3 times s plus 2. And then what we want to do now is use partial fraction expansion to get this polynomial into smaller terms that will be easier to evaluate their inverse Laplace transform. So let's just pick a couple of constants, a and b. We'll have a over s plus 3 and b over s plus 2. Now there's several ways to solve for a and b. I'm going to use the way I prefer, which is the following. We can say a is equal to s plus 3 times 2s, the polynomial 2s plus 5 over s plus 3, s plus 2. So these will cancel. You'll be left with this part, and we're going to evaluate that where s equals minus 3. And you should get 1. And you do a similar thing for b, s plus 2 this time, 2s plus 5, or s plus 2, s plus 3. And now these cancel. We're left with this. And so we want to evaluate where s is minus 2. And you should also get that b is equal to 1. So we have our factors. A is 1 and b is 1. And so now f of s is equal to 1 over s plus 2 plus 1 over s plus 3. And you can multiply this out. You can combine these, and you should come back with our original polynomial. So now we need to find f of t, which f of t is, of course, just the inverse Laplace transform of f of s, which in this case we can use the linearity property and take the inverse Laplace transform of each term individually. So let's do that. The inverse Laplace of 1 over s plus 2 plus inverse Laplace of 1 over s plus 3, which of course is, so f of t then is, you can look up in the table, you'll find that it's e to the minus 2t plus e to the minus 3t u of t, not ut, u of t. But remember, we have that e to the minus 2s term that shifts just basically shifts f of t to the right by 2. So our final answer will be the following: e to the minus 2 t minus 2 plus e to the minus 3 t minus 3, and times, I'll bring it down here for space purposes, times u of t minus 2. I'm sorry, this should be not t minus 3 here. That is minus 2, because it's all just shifted left to the right by 2. Thank you.